Hey, good morning, guys. Just want to first thank everybody for doing Monday's assignment. I enjoyed reading everybody, see what they've been up to, see how they've been handling things. Um, Found a lot. You guys mentioned a lot of positives, which is great. You guys seem to transition okay into the remote learning. But if you have struggles, if you have questions, again, don't be afraid to ask. My plan is to do more Zoom sessions, definitely on that fifth day, the day 5 that we now have in our schedule, where it's just going to be like review questions, time to catch up. So we'll definitely make sure that we continue to add those into our schedule. All right. So we're still doing the same thing in chapter 9 here. We're still significance testing, except now we're not working with proportions. We're going to work with means. But we're going to follow the same steps that you guys took before break when you quizzed on how to construct a confidence interval. I'm sorry, not a confidence interval, significance test for proportions. Okay, so you'll see here that the first thing we want to do is make sure the same conditions, well, 2 of the 3 same conditions hold true, right? So it's got to come from a random sample of data. The 10% condition needs to be satisfied, meaning the sample size needs to be less than 10% of the population. But this is the most important condition, okay? This is the one that we should have some familiarity with, okay? Because it was similar when we did confidence intervals. For proportions, we called it large counts, but for means, we call it normal large sample. And the name is what it is because you kind of follow like basically the setup of it, meaning, is it normal? Does the problem tell you that the distribution is normal? It does not. Okay. So is the sample large enough? Well, if it's at least 30, then it's considered large, meaning this condition would be satisfied. Finally, if it's not normal, if the sample size is small and it's not large, then you would have to graph the data to assess normality. All right, and you would do that in the Inspire. And as long as the graph shows no strong skewness or outliers, you can proceed finding the significance test. Okay, so listen, this is always going to work out when we do these problems. When I ask you to actually carry out a significance test, I'm not going to try to fool you. It is going to be random. It is going to be 10%. This condition will be satisfied, but you have to be able to explain in which way it was satisfied. Okay, so hopefully today you kind of have that understanding after kind of watching this video. All right, our first example. A classic rock radio station claims to play an average of 50 minutes of music every hour. However, it seems that every time you turn on the station, there's always a commercial playing. To investigate their claim, you randomly select 12 different hours during the next week and record what the radio station plays each of the 12 hours. There's your data, okay? This question just says check the conditions. Well, the random condition is satisfied because we were told that random hours were selected. We know that 120 hours of music played during the week would certainly be less than 10%, right? So we picked 12 hours, but that 12 hours that we sampled is less than 10% of all the hours of music played on the station during that week. So that's satisfied. And now here comes this normal large sample condition. In the problem, it didn't say that it follows a normal distribution. Okay. That doesn't mean that it's not satisfied, it just means that we got to find another way. So it's not normal. Is the sample considered large? Well, we only sampled 12, and you need to have at least 30. All right. So this condition is not satisfied by the problem telling us it's normal, nor is the sample large enough. So we would have to graph. Now, I don't know why these graphs did not come up on my on the notebook or the notes here. So regardless, I'm just going to show you real quick. So we would go to list and spreadsheet in our calculator, and we're just going to make one column of the data for the minutes of music played for each one of the 12 hours that were sampled. So these numbers were given to us in the problem. And when you graph, you have to make sure that you name your column. All right, so I'll name this music. Or you know what, a better name would probably be minutes. Okay. Now, in order to graph it, we're going to hit menu. All right. Actually, this would be if we wanted to actually do the significance test, which I won't show you right now. I'll just show you how to graph. So let me back out of this. Okay. Once we have it in the list and spreadsheet, we're going to hit Control I. Once this goes away. All right, Control I. We're going to add data and statistics, and we should see random scatter right now. Okay. And remember, we've done this before. So now you're going to drag down here, and where it says click to add a variable, you'll click. All right. This dot plot should be sufficient, but because we're checking for outliers, because we're checking for strong skewness, I think it would be best if we would change the plot type and make it a box plot, just because the box plot shows the outliers. So this definitely is not symmetrical, but it's not strongly skewed. Okay, so that means that we can say that it is approximately normal, meaning this condition is now satisfied. So again, the problem didn't tell us it was normal. The sample wasn't large enough. However, we graphed it. We did not see strong skewness, so it's safe to proceed. Okay. If we continue the significance test with this problem, here would be the part where you would start out by hypothesizing, right? You would set up your HO and your HA. Notice the HO is no longer P. You know, we're now using this notation. It's mu for mean, or for the population mean, okay? The HO is always an equal to, and then the HA would be your hypotheses here, whether you're claiming that it's a less than, a greater than, a not equal to. In this case, we think that the station plays less than 50 minutes of music for each one of the 12 hours. All right. Now, the next part that you see in your notes, and you've probably noticed this prior to, is me trying to show you an alternative way to do it. If you don't have a TI Inspire, you can do this. You just have to do a little more calculations. All right. So you would have to find the mean, the sample mean. You'd have to subtract the population mean. You'd have to divide the standard deviation by the square root of our sample size, and you would get this test statistic. Okay. Now, most of us that have the Inspire, I'm not holding you responsible for this. What I will do in this particular problem is, let's go back to our spreadsheet here. Okay. And all we would have to do would be to hit menu, statistics, stat tests, and last section we did one prop z tests. That's because we had one proportion. Well, we don't have proportions with means, all right? So we're going to do what's called a t-test. All right, so a t-test would come out. It's always going to ask you, do you have data or do you have stats? Some problems you might have stats, some problems you might have data. Here we have data. All right. Our HO here is 50. Our list, okay. What we're hypothesizing is that it's going to be less than. And we can put the results in B because we don't have anything in B. All right, so here is this test statistic, which is very close to the number over here. Right? There's going to be slight differences because of rounding errors and things like that. Here's our p-value, right? And we should remember that the p-value is really the most important thing, because that's going to lead us to our conclusion. So this p-value we would now compare to the significance level. And because it's less than 5%, we end up rejecting the null hypothesis. We have convincing evidence that this particular radio station plays less than 50 hours of music per hour. Okay, so we're not quite there yet. I was just kind of showing you that, but here's one of the features that we'll be using in the calculator, and that is list and spreadsheet. All right, back to the notes. Here's just some practice with the calculator. You might not always run the test to find a p-value. You might be given the scenario here. You might be given the test statistic. You could be given the sample size. Okay, how would you do that? Well, you're going to do it in your calculator. Okay, you're going to hit menu, probability, distributions, all right? And we're going to use TCDF, all right? TCDF. So what was that? 555. Menu 555. Okay. It says find the p-value for a test. Now it's a greater than test. Okay. Sample size is 75. Test statistic is 2.33. So because it's greater than, we're going to 2.33 will be our lower bound. This will be a big number. And degrees of freedom is your sample size minus 1. So 75 minus 1, 74. There's our p-value. Again, how did I do that? Well, menu, .555. All right. You're going to have to put a lower bound in or an upper bound in. Your test statistic will always be one of the two. If it's a greater than, this would be your lower bound. If it's a less than, okay, this would be my upper bound, and I would have negative 100 as my lower. Think about the curve here, right? If I have 2.33, here's that, and I'm trying to find everything above it if it's greater than. If it was a negative test statistic, it would be over here, and I would be finding everything that's below it. Okay, let's try the next one. So menu, 555. Now this one is negative, but it's a not equal to. So there's going to be something else here that we got to be aware of. Now, let's just go with the idea that it's negative. So I'm going to do a negative 100, negative 0.51. Sample size is 10. 10 minus 1 is 9. Now, that's not our answer, okay? Because this would only be one tail. We have to find the other tail, okay? So to find the other tail, we would have to take our answer here and multiply it by 2. All right? Now, that number is very high. It's definitely going to be greater than that. Would probably lead us to an answer of failing to reject. But again, we're not really worried about that right now. We're just trying to find the p-value. And this was one way. It was 555. All right, menu 555. All right, last thing for today. And today's assignment is just going to be for you to watch this video and for you to take notes and practice on the calculator as you go through it. Now, I'm going to try to write as much as I can here, but it is tough on the screen. So it says the makers of Aspro brand aspirin want to be sure their tablets contain the right amount of active ingredient. So they inspect a random sample of 36 tablets from a batch in production. When the production process is working properly, these tablets have an average of 320 milligrams of active ingredient. The amount of active ingredient in the 36 selected tablets has a mean of 319 milligrams and a standard deviation of 3 milligrams. Okay, all right, so we have to state the appropriate hypotheses. So we're going to set up an HO and an HA. Remember, we're using mean here, so it's going to be an M. This one's always an equal to, and we're talking about the correct amount of active ingredient. So 320. Our HA is going to be what we suspect or what we are claiming it to be. This could be a less than, a greater than, or a not equal to. All right, so let's go back in the problem and let's kind of make sure we're identifying this correctly. It says when it's working properly, it should have 320. The amount of active ingredient has a mean of this and a standard deviation of 3. All right. It says the makers of Aspro want to be sure that their tablets contain the right amount. Okay, so the right amount would just tell us anything. The right amount is 320. So the incorrect amount would be anything other than 320. It doesn't say less than, it doesn't say greater than. It's just something different than 320 milligrams. So there's my hypotheses. All right. The next part would be the conditions. And again, I'm just going to try to abbreviate a little here, but make sure you're paying attention with what I'm saying. So, is the problem random? And the answer would be yes, it is. Why? Well, the problem tells us it is, right? It says that they took a random sample of tablets, okay? A random sample of 36. So that gets checked off. This reappeared. All right. The 10%. That's also satisfied. Why? Well, we would think that the 36 tablets is definitely less than 10% of all the tablets that this manufacturer makes. Okay, so the 10% condition is also satisfied. And finally, the normal large sample condition. Now, remember, there's like 3 ways in which we can check this box off. Only one of the 3 have to work. So does the problem tell us that this follows a normal distribution? It does not. Is the sample large enough? It is. 36 tablets is what we call a sufficiently large enough sample. It's at least 30. So because it's at least 30, this condition is now satisfied and we can continue doing the problem. There's no need to graph here. All right. Now, we're going to find the test statistic, and I'm going to show you how to get the p-value. You don't have to use the table because you have the calculator. If you don't have the calculator, you might need to use the table. All right, so we're going to just go to, just clear all this stuff here. We're not going to list and spreadsheet. There's no reason to graph here. So we're just going to hit menu, statistics, stat tests, and we are doing a t-test. All right. We have stats. Okay. Our HO is 320. Our mean is 319. This was given to us in the problem. The standard deviation is 3. Our sample size was 36. N. It does not ask for degrees of freedom here. It says N, so 36. And our HA is a not equal to. Okay. So take a look what we have. This t value is our test statistic. Here's our p-value, the most important one we need to locate, right? Why is that? Well, that leads us to our conclusion. And our conclusion would be, well, since this is greater than a 5% significance level, we fail to reject the HO. We do not have convincing evidence that Aspro brand aspirin contains an incorrect amount of active ingredient. Okay? So, guys, I know that was a lot today, but I'm going to stop there. So hopefully you were able to follow along, take notes. Definitely make sure you watch this video and take notes, pause it, stop it, write down some questions that you might have, and we'll do some example problems tomorrow. All right? I hope everybody has a good day, and I'll talk to you later.